cool. Speaking of the incursus rendering, I think I have a couple of ideas. I think I do have a couple of ideas. So in the examples, we have a triangle, right? So let me take a look at the triangle. Maybe I'm gonna start with this shit. Right, so here is a simple example that like tests transparency and stuff like that. Can we port this thing to incursus? That will be actually rather interesting, because if I take a look at the examples, right, so in examples, right, I have the macro called SDL platform. So if it's enabled, this thing is going to compile with the SDL. What if we introduce the following thing, right? We're going to introduce several platforms. We're going to introduce the WASM platform, then SDL platform, and then incursus platform. Or maybe it does not necessarily have to be incursus, actually. It could be just terminal, right? Because we can just like render everything in the terminal and use escape codes. It doesn't really have to be incursus, right? So, and this thing is going to be something like 0, 1, and 2, right? And then we're going to essentially you can define the platform when you compile this entire thing, right? And we can say if platform is equal to SDL, we're gonna do this thing. Otherwise, else if how do you do the elif? I think it's elif platform is equal to term platform. We're gonna do another thing, and otherwise, if platform is equal to WASM platform. I think in that case we just do nothing, right? But otherwise we can say something like error unknown platform. There we go. All right. So for the WASM we have to do nothing. But for the terminal we'll have to organize the sort of like a loop. Where we call the method render all the time, and then take the array and we just like turn it into ASCII, right? So we can try to do that. I think it's going to be rather interesting. All right, so let me see how it is going to go. So let me recompile this entire thing. So it kind of compiles, except we didn't provide the correct platform. So in a build, triangle. Okay. So here is the one triangle, here is another one. So I want to kind of separate those things. So this is 3D and this is the triangle. So in here, I'm compiling a triangle for WASM, right? So this is a platform. The platform WASM platform. Here we do platform SDL platform, right? And because of that, maybe I also have to change this thing, so it's going to be SDL, right? So here we have extension WASM because it's a WASM platform. Then we have SDL in here, and I'm going to also introduce term. This is a term platform, so we don't have to link with SDL here anymore, I'm pretty sure. And probably we also have to get rid of this thing, right? And let me go to the triangle examples and let's print to do term platform is not implemented yet. It is not implemented yet. We're about to implement that. And let's do build .sh. Okay, so it is complaining about something, probably because I have to include the stdio. So we have things like triangle SDL, and it looks like SDL, and we also have the triangle term, which says the term is not implemented yet. Right. So there we go. There we go, and let's go ahead and organize some sort of an event loop, right? So for now, let's say that it's going to be just an infinite loop, infinite for loop, right? So then we're gonna have something like pixels, and we're gonna say, okay, render that with 16 frames per second, right? Something like this. So this is a 16 frame per second. And what we have to do next, in fact, we have to transform those pixels into ASCII characters. We have to transform them to ASCII characters. And I'm thinking how we're gonna approach all of that. We can just basically map each individual pixel to a character, right? So this is one of the things we can do. But this raises the question how exactly we're going to map them. Right. Maybe we can map certain colors, right? Maybe we can map certain colors, or maybe we can map the brightness, so to speak. Maybe we can map the brightness. But that's gonna be very interesting. So for now, I'm gonna just do the following thing. So it's gonna be size y, y less than height, plus y, size tx, x less than width. Okay. And we need to have some sort of a function, right? So color to char, right? And you can do pixels y multiplied by width plus x, and then I want to just print that character to std out, right? I want to print that character to std out, and then in here, I wonder if put.c actually accepts the file, right? So put.c does in fact accept the file, so that should be fine. And then I'm going to provide the new line in here, right? So this is std out. This is std out. Okay, so, and the question is essentially in how you implement this thing. uint32 pixel, all right. So brightness, the problem with the brightness is that the problem with the brightness is that we have pretty much the same brightness anyway. We have pretty much the same brightness anyway. You know what would be cooler? It would be cooler if we essentially collected, but we have a little bit of the anti-aliasing, right? So we do have a little bit of an anti-aliasing. So that means on the edges of the circle, we're going to have different alphas, right? Different alphas. Maybe we can actually strip off the alpha of the pixel, right? Like so. And then move 8 multiplied by 3. So this is the alpha. And depending on the level of the alpha, right? Depending on the level of the alpha, we can choose a particular thing, right? So essentially, we're gonna have like a gradation, like 0, dot, underscore, all right, like a, so something bigger, maybe like double dot, then a, then at, and then this. So as you can see, so we have this like levels of gradation of intensity, so to speak. Maybe instead of underscore, we're gonna put it like that, right? So it becomes more and more sort of intense. I'm not sure about this thing. Yeah, I think this is a little bit better, right? So this is the levels of gradation. And this is essentially a table, all right? This is a table. And we need to know the size of that table, right? So as far as I know, you can actually do this table like that, right? And what is going to happen if you take the size of that table? I don't remember the rules of C, right? So what's the size of that specific table? Right, what's the size of that specific table? So let's actually do experiment, right? Let's conduct an experiment, super quick. Right. Instead of Googling all of that, it is better to actually test that, right? So that's the easiest way to confirm, right? Size of table. What's going to be size of that specific thing? And let's do it like that. Okay, 7. How many characters do we have in here? We have 6 of them. That means it also includes the 0. Right, that's quite important. That's quite important to remember. That means we always have to do -1 to actually get the actual amount of characters. That also means if you have like an empty table, it's never empty. It contains at least null terminator. That's quite important. So, and the reason why we want to be able to do that, right, is because we want to be able to take those things, right? So table, rand, and just mod of this thing like so, right? And then we can do rand times 0. There we go. And we probably have to include some time as well. So then in here we want to return the character. Right, and every time we have a different character from that pile, and in fact we can quite easily generate like 10 random characters, like so. Right, there we go, 10 random of them, and it's different every time, and we don't have any buffer overflows. Okay, I'm sorry. I don't know what's happening with me. Okay, so let's go in here. Okay, so we know how many of those things we have, so I'm gonna actually put n-1. Right, and effectively, what I wanna do, I wanna divide this thing by n, right? So I effectively divide this entire thing by n. But is that a good idea to divide it like that? Is that a good idea? Because, in fact, what I want to do, I want to divide 255 by n to get the interval, right? Some sort of interval. M, right? And then I'm going to divide by that specific interval, right? Which means that I'm in fact dividing by this thing, which means that I'm in fact multiplying by this thing, right? Which also means that I first multiply by n and then divide by 255. Okay, and that effectively gives me the index within the table, right? It gives me the index within the table. I wonder, does it always give me the index with, like... This is actually a very good question. So did I come up with that formula correctly? This is very interesting. I want to test that as well. Experiment, right? Because I went into this weird state, like a deep state, where I just like write code, and I'm not really sure if I understand this code, right? So my brain just came up with this idea, and I actually doubted, is that the correct way of doing that? So what we're gonna do, we're gonna just iterate through 0 to 255, and I just want to print those things. I just want to see them. I just want to confirm that they actually do what I think they do. I multiplied by n divided by 255. So is that how I can actually do that? Right, and it goes up to 6. It goes up to 6, so that means it can be equal to 6. Right. So which means that probably I want to actually divide by 256, so it never actually goes to 6. All right, and now I can quite safely use that as an index within the table. And of course, I want to actually render that as a character. That is beautiful. So yeah. And as I add more and more character in here, this actually starts working better and better. Up until I add more than 255 characters, actually. Right, so yeah. Okay, that's a pretty interesting way of doing that. And of course, then I can just do table and just return that thing in here. There you go. Isn't that cool? Isn't that cool? I think it's pretty fucking... I'm sorry. Okay. So my brain just came up with the code, and sometimes I actually start doubting whether it's a correct code or not. But I think it's a correct code. Call to char. So okay, so here we're rendering a single frame. So let's actually stop after a single frame just to confirm that it's the frame looks correctly, more or less. Right. So let's go. Let's redo everything. So bin, and what we're going to do, triangle term. Okay, so it is rendering something, and it is too much. I do not believe that that's the size of the thing that we're currently rendering. Something went horribly wrong, that's for sure. And is that the well, I mean, that's too much actually. So what if we just run this thing and do out txt? Right. Boom. Okay, that works. So the Emacs is a very slow terminal, right? So Emacs is rather slow terminal. Okay. So, and all of that is just like, yeah, this is because I'm an idiot. Okay, so I have an idea. The alpha is not a particularly good thing to use as an indicator. Well, I'm not a completely idiot, right? So I came up with a pretty cool system. It's just I'm using the alpha for that specific system. So what I should be using instead is probably brightness. And the easiest way to get the brightness is just to get all of the components together and find the minimum or maximum between them. I think that's the easiest thing to do in here. You know what I mean? I think that's the easiest thing to do. All right, so let's go. I'm going to extract red component, ff pixel. To indicate that I'm extracting red component, I'm going to just do 0, 0, 0, 0, 0, 0. There we go, I extracted the red component. Right, and that's the first thing we have in here. Right, so let's call it B. Is that a good idea? Is that a good idea? Let's actually first extract all of those things. Right, so then we're going to have G. Right, so this is going to be G, and for the G I also want to do something like 8 multiplied by 1. Right, for the symmetry I'm going to say that I'm shifting 8 by 0. Right, I know that it's a useless expression, but it's needed for the symmetry. And then for the B, what I essentially have in here is something like this, but 2 of them, so I have RGB. Right, and then I'm gonna have bright, which is originally R. If bright, let's say if it's less than G, I'm gonna assign bright to G, and then it's gonna go the same for B. You know what I mean? It's gonna go the same for B, and then instead of this stuff, I can actually just use bright. Is that a good idea? Maybe it is. All right. So we're finding the maximum. All right. So let me try to recompile this entire thing. I'm gonna just do build.sh. And let's just output this thing in here. And okayga. Oh, would you look at that? Doesn't this look familiar? I think it does in fact look familiar. So yeah, I actually rendered it. So the easiest thing to use in here was actually the brightness, right? It was actually the brightness. But the problem is that the resolution is too big for the characters, right? So the resolution is too big for the characters. So triangle SDL, right? So this is a very high resolution, very, very high resolution. So we have to do something else in here. So the triangle, and what's funny is that we're compiling all that from the same source code, right? So it's the same source code. So we need to have some sort of like a scale down factor, and we can scale it down by the factor of 10. I think that would make sense to scale it down by the factor of 10, because we have a width and height, right? As you can see, it's a width and height, but we need to create sort of like a scaled down version of width and height. Right, scaled down width, which is effectively width divided by scaled down factor, and then we're gonna have something like height. There we go. Scaled down width, scaled down height. And we also need to have the canvas of the characters, right? So this is basically the char canvas, right? And this is scaled down width multiplied by scaled down height. And when we are rendering, right, when we are rendering, we're going to be rendering into this canvas, right? We're going to be rendering into this canvas. And what we need to do essentially, right? So the scale down factor forms a square of pixels that we need to compress. That's what we need to do, comrades. We need to compress them. I don't know why I'm going to say it like that, but anyway. So how can we compress the pixels? We can find the average of them, right? That's an interesting idea, don't you think? Right, so we can basically sum up all of the components. We can sum up all of the components and just divide by the amount of pixels. I hope it wasn't too loud when I touched the microphone. Okay. So let me see. So this is a color to char. Maybe we're gonna keep using that. So uint32t compress pixels, right? And what I want to do in here, I suppose, is I'm gonna just accept the place where, like the left top corner of the chunk that you are compressing, right? So that's what we're gonna be having in here. But because of that, by the way, we can actually accept the Olive.c canvas. Right, that's actually a pretty cool idea, because yeah, so Olive.c canvas is a pixel view. It is in fact a pixel view. That means I can just basically turn this chunk into that and just compress the whole canvas. Yeah, so that makes sense. Maybe I should actually rename them to pixel views, right? So that would make a lot of sense, I think. Anyway, so let's start iterating all of the pixels, right? So it's going to be y less than OC height plus y, and then we do size t x OC width plus x, right? And what do we have in here? So it would be maybe nice to actually have a macro that allows you to extract red, green, and blue components and whatnot. Right, so let's have something like this. So we're gonna have r equal to 0 gba, right, or gba, and then I'm gonna do r plus Olive.c pixel OC x and y Olive.c red, right? So we're extracting red, and then G, green, B, blue, alpha. There we go. And after that, we want to divide all of that stuff by the amount of pixels that we have, right? So it's going to be width multiplied by height. Right? I'm going to do that for all of them. And then we want to compose all of that back into the RGBA pixel. Right, so how can we do that? Maybe I can also come up with the macro, something like RGBA. Right, RGBA, that basically composes all of that back. Right, so the only thing we need to do, we need to implement all of these macros now, somehow. Okay, so Olive.c red. Right, so here is the color. What I do with the color, I just mask it, FF, well, I mean, 00, 0, 0, 0, 0. Of course I want to do it like that because the color itself can be an expression, and I guess that's it. So that's basically the color, but one of the things I can do is basically shift it by 8 multiplied by 0, and also I'm going to wrap it one more time. Okay, green is 0 but 1. Might as well realign those things one more time. Blue, like so. This is blue and this is 2. And alpha, oh, of course I forgot to put this stuff in here, and the alpha is 3. There we go. So we have stuff like that. Cool. I always read it like Olive.c in my mind. Well, there's no like a correct way to read that. You can read however you want. By the way, thank you everyone who's role-playing bot today. So I'm sorry that my bot doesn't work. I need to restart my system. So thank you so much. On the next stream, we're gonna have like a proper bot that answers the question. Thank you. Okay, so let's implement Olive.c RGBA. Right. So R, we're gonna just take this thing. So it's gonna be FF, and then we're going to be shifting this to 8 multiplied by 0. So G is 1. Might as well just do it like that. B is 2 and A is 3. And we merging all of them with OR and then something like this. So I'm programming in Lisp now. This is Lisp now. There we go. So maybe fix bot in the stream. I don't think it's that interesting to watch, and to be fair, that interesting for me to do. Right. Okay. Why are you and the color components with 0FF? Because I don't know the type of R. Because I don't know the type of R and the value of R, how big is R and stuff like that. It could be any type and contain any value. But what I want to do, I want to say, okay, I only care about the lowest byte. So that's basically what I said. All right. No. Because for instance, I use size T in here, right? And it may contain anything, just to be sure. Okay, so here's the compress pixels. Here's the compress pixels. How we should do all of that? So we just compress. Let's call it compress pixels chunk, right? And let's have a separate function called compress pixels, which takes whatever we render it after this thing, right? Whatever we render it, and well, it probably should like accept this stuff, and renders that into the char canvas. That's probably what we want to do in here. Alrighty. So compress. Yeah, that's a very interesting idea. Compress pixels. Okay. So what do we want to do? I'm going to start iterating size y less scaled down height plus y. X0 x scaled down width plus x. And what are we gonna do? So we need to now basically take sub canvases in here. So how are we gonna be taking sub canvases? We need to construct the actual canvas, right? Olive.c canvas OC, Olive.c canvas pixels, width, height. There we go. And then we need to start taking sub canvases. Actually, finally, taking sub canvases became a useful feature. Right, it finally became a useful feature. So I just provide OC, and X is basically X multiplied by a scale down factor, Y multiplied by a scale down factor, and width and height are the scale down factor. So this is the sub canvas, right? So we're gonna call this thing SOC, right? So this is the sub canvas, and then I can finally compress the pixels of this entire thing, right? I'm compressing the pixels of this entire thing. I'm compressing the pixels of SOC, and then I can do char, maybe color to char. So I took the chunk of the size of 10 by 10, right? Then I compressed that chunk into a single color, but basically I averaged out the colors, and then I converted that color to a character based on its brightness. And now I should be able to use the char canvas, right? Char canvas, and put it there, right? So it's gonna be Y scaled down width plus X. There we go. So, and after that, after I rendered everything and compressed the pixel, I should be able to just go over this entire thing and just render it, right? So I'm gonna do it like that. Size T, Y scaled down height, plus Y, scaled down X, so width X, and I'm gonna put C, tootsie pootsie, pootsie pootsie, and Y scaled down width plus X, std out, and then we have to put a new line in here. Queen is dead. Really? Is she dead? Rest in peace then. I'm personally waiting for another political figure death. Really looking forward to. Definitely not the queen. Anyway. You know, looking for that free borscht already. So let's try to compile that and see how it's gonna go. Okay. So we'll have to probably go here. So should work, right? Knock knock coming, yeah, exactly. This is the last stream, by the way. This is the last stream. Okay. So this is gonna be term, and okay, so it didn't fail, and it actually generated like 10 times smaller file, which is kind of cool, which is precisely what I wanted to see. And let's take a look at that. Looks pretty cool, not gonna lie. That actually looks super nice, and it's just like it really scaled down. That's so cool. We can try to scale down even more, maybe. But we have to make sure that this thing is divisible by scale down factor, right? So this is one of the like important things. Static assert, I might actually do a static assert in that, right? So equal to 0. Width must be divisible by the Let's put it this way, by the scale down factor. I'm not really sure why I'm basically repeating whatever I said in mathematical language, but now in natural language, but it do be like that sometimes. Let's put it like that, let's put it like that, and let me... should be like height. All right, so okay, so the reason why I actually put all of that checks is because I want to check that is it divisible by 20, right? So that's basically what I'm doing. Okay, so is it not? Oh yeah, we'll probably have to include the assert assert.h. There we go. All right, there we go. So it is in fact divisible, so let's try to run this entire thing. And if I open it, so now at least it fits into the screen, into my screen. So that's very, very, very nice. Very, very nice. I really like that. So, which also means that we can quite easily animate that, right? So what's going to be the first approach in animating this entire thing? It's essentially going to be removing this return, right? If we just let it go, it's going to keep animating, right? It's going to spam into the terminal, but it's going to be animated, right? Which is already interesting. And so in the next step is going to be actually properly refreshing the screen. All right, so let's see. You know what's cool is that once we develop this system, we can just copy paste it into 3D example, and it should work as well, right? Because this particular thing, as you can see, it doesn't really care about what's rendered to. It takes the array of pixels and turns it into array of characters, right? So that's the beauty of abstraction, right? So I'm pretty sure that the memory is actually the most powerful abstraction, right? You have one part of the system filling up the memory, and you have another part of the system reading that memory. And this is actually the most powerful way to decouple those systems, right? So, and for instance, we have a library that just fills up the memory. It doesn't do anything but fills up the memory. And as you can see, we can plug it into OpenGL, WebAssembly, the terminal, like anywhere. Like we don't care. So memory is the most powerful abstraction like humans actually came up with. All right, so let's take a look. Olive.c, and let's do bin triangle term. That is too fast, I would say. That is rather too fast, but it's doing the thing. It's doing an interesting thing. Right, it's kind of animated, but we need to sleep a little bit, right? So we need to sleep a certain amount of pixels, but not necessarily sleep. We can actually try to compute the time distance between this stuff, right? So as we do in SDL platform, right? If we take a look at the SDL platform, I think we just do get tick. Yeah, we just do get tick, and then within that get tick, we take the difference and divide it by 1000, and there you go. 16 FPS terminal graphics, yeah, exactly. That's what it is. So let's actually try to do the same thing, but we're in a territory of POSIX, right? We're not using SDL in here, we're using POSIX. So let's actually try to see what we can do. So we can use clock, get clock, I don't remember how it's called. I think it's a get time. Yeah, this time, this one. All right, and we can do this thing. So real time, monotonic time. I think we can do monotonic clock. That cannot be set or represents monotonic time since the some unspecified start point. This clock is not affected by. Okay, so we can try to just take a monotonic clock and see how it goes. So we can do that on each individual frame. Monotonic. I'm not really big expert on different clocks. I'm not a really clock expert. But I think monotonic should be fine in our case. Right, so we need to also have struct time spec. Right, so this is going to be TP. Big clock expert. Yeah, I know, funny. Haha. Nice clock. Thank you. Thank you. I really appreciate that. It's a monotonic one. Big monotonic clock. Without further interruption, let's celebrate and set some clock. Anyway. This is the error. Do I have to do that? Maybe I have to do that. Error. Could not get clock. Yep. So we're also going to specify why. std error, error no. And we're going to just do that. Interestingly, so we can say something like TP current, right? So this is the TP current. Or maybe we can call it TP previous, right? So this is the previous. So, and that also means that we need to have something like TP current. Right, so this is the TP current. And what do we even have in there? What do we even have? We have seconds and we have nanoseconds. Okay, so I'm not even sure if I care about like nanoseconds, right? So what I do care is milliseconds. Oh, by the way, I cannot see shit in the chat. Oh, reconnected, disconnected, but I still can. Okay, can you see? I think Chatirina just debated me, literally. Come on, streamer, throw us some numbers already. Okay, I'm throwing numbers, all right? Bear with me, I'm throwing numbers. 9 o'clock, yeah, it is very, very sad. Okay, so milliseconds is 1000. So 1 million is microseconds then. Then nanoseconds is 1 billion, right? It's billion. Okay. Okay, go. So that means, what do we want to do? I want to have something like size t. You know what? Maybe I'm gonna like straight up do that in milliseconds, right? So it's because of that. We're just gonna have a single TP, right? And then ms previous ms, right? Previous ms is going to be equal to TP TV nanosecond divided by 1 million, right? So we basically remove nanoseconds and microseconds, right? So we just remove all of that. And then we add TP TV seconds multiplied by 1000, right? So because we take milliseconds out of that. So this is the previous milliseconds. So then, you know what, I think it makes sense to actually put all of that into a separate function, right? So we can do something like get current ms, right? So, and we can literally just put this entire thing in here. And because of that, maybe here we can just do exit, right? Just crash. And here we simply return that. There we go. So that's pretty cool. So that makes everything a little bit simpler. Get current ms, then size t current ms get current ms. Then what we want to do, we want to take current minus previous ms, right? We'll just do that. And then I want to multiply it by 001 and turn it into delta time, right? So effectively turned it into a delta time. Okay, so this is the delta time. And then I assign previous ms to the current ms. And in here, I just like do it like that. render the time, and then we just render the synthetic. I just saw the completion. You didn't see anything, okay? You didn't see anything. All right. Don't tell me. I'm actually using auto completion. Variable has incomplete type, so we probably have to include something. I'm pretty sure we have to include something. I have to include time. Oh, right. So let's put that thing in here. And okay, so what else do we have? So this one is just that, of course. It's a buffer local completion. Yeah, it is kind of like, it doesn't count. It doesn't count. You didn't see anything. String error null. There we go. Exit has a type void something something implicitly declared, but didn't I include stdlib? Are you telling me? Yeah, I didn't include stdlib. Okay, so you're right. So let's actually do that. Okay, so now let's give it a try. It's gonna be bin triangle term. So, but it, as you can see, it's twitching from time to time, right? This is because like we're literally spamming all of that stuff. We're literally spamming. And we have a variant with SDL, right? Furthermore, I'm pretty sure we can do something like, can I? Well, I don't remember. Right, so I can do that, then bin triangle term, right? So there we go. So this is like literally the same code, the same logic, but we just actually connect them to different terminals, right? So we just connect them to different terminals. That's actually very cool. So that's what our library allows us. It's not really our library. That's the power of memory as an abstraction, right? So, okay, so if I do Control-C, if we scroll up, as you can see, it's just like, it keeps spamming. It doesn't really do anything special, it just spams. Right, so what we need to do, we essentially need to use escape terminal codes to sort of move the caret to the left top corner and try to do that again. Let me see how we can do all of that, right? So I already done that before, specifically in, I think in Porth, right? So in Porth beta, so I have an example, and an example I have game of life, right? And as you can see, so this basically constantly refreshes. I don't remember how exactly I did that, so let's take a look. So this is the codes that I use in here, right? So the escape code 27, then yeah, so we can try to do that. So essentially, we rendered it once, and what I want to do is just print f escape code. How can I do that? I think it's like 033, right? Isn't it? I'm pretty sure it is. Yeah, it's 27, so it's supposed to be 27. Then that, and then comes the amount of rows, right? So we're gonna put D in here, and then A. So the amount of rows we have, it's a scaled down height, right? It's a scaled down height. We don't really put any new lines in here, right? And then this is D, and this is scaled down width. Right, and that way we essentially repeat that. So let's give it a try. Alrighty. So triangle term. And yeah, so that looks a little bit better. Interestingly, so the cursor is going all over the place. I think I know why. Right, so this is because we have to do this thing right here. So I think, but that might create a really strange effect. We'll see. Right, bin triangle term. That's fine, I guess. Yeah, that's fine. More or less fine. Yeah, I have a strange feeling that maybe, just maybe, it would be simply easier to just use sleep for the amount to synchronize with, you know, 60 frames per second instead of like computing the distance in here. Right. And also sleeping will make it less busy looping, if you know what I mean, right? So maybe it's gonna be better. So let's give it a try. So what if I remove this entire thing and simply say, okay, do use sleep, and use sleep as accepts microseconds, right? Microseconds. Okay, so that means I have 1000 divided by 60 multiplied by 1000, like so, right? And I can always, I'm pretty sure, can I just multiply it first and then divide it? Yeah, I should be able to. That makes sense. Right, so okay, good. So dt, and because of that I can just do 60. Yeah. Hopefully the compiler will just fold the constants. Well, it will. Use sleep is implicitly declared, nobody cares. We can always fix that later. Yeah, I think it's a little bit better because, yeah, it's at least the cursor doesn't really go all over the place anymore. Right. So I'm gonna try to put it in here. Triangle term. Yeah, there we go. That looks nice. Absolutely love that. So, of course, the aspect ratio is a little bit fucked. So, because of that, maybe I have an interesting idea. We can print the same character twice. To make it a little bit wider, if you know what I mean. Right. There we go. That was easy. Super easy. Haha. That looks cool. I really like that. Bog. Kawaii freaking desu. So you sleep. What do we have to include? We have to include uni std. Uni std. Let me put that stuff in here. Get. We don't need that stuff anymore. We need that stuff anymore. We need that stuff anymore. It became simpler, way simpler. So we can try to make the entire scene even smaller. What if the scale down factor is going to be 13? How about that? That's how we go from UTF-8 to UTF-16. Yeah, exactly. So this thing is not divisible, right? So, and that's precisely why I put static assert in here, because I don't want to think about that. But I'm pretty sure it's going to be divisible by 14, right? So there's some limitations that you have in terms of choosing the factor, but yeah. Now look at that. Isn't that cute? I think that's pretty cute. That is very, very cute. Right, you can just scale it down like that. And the original application, right, for the screen images, it looked like this, right? So this is the original application, and we just redirected the rendering into the terminal, right? And we also had to compress everything and stuff like that. So yeah. So char, call it a char. I kind of want to change some of the values of the table, right? So maybe instead of dot, we're gonna have something like this. All right, because I have a strange feeling that it's not particularly useful to do this way. Yeah. Nah, dot was better. Let's keep the dot. I think the dot is better. Anyway, okay, so yeah. That's precisely what I wanted to do. And now, as already said, we don't care. We literally don't care what is being rendering. Let's try to port this example as well. Sounds rather complicated, right? There's a lot of things in here, but again, it renders into the same canvas of pixels. It literally doesn't care. Okay, so let me see. I'm gonna go to 3D. Yeah, Bobo is there for to test the you know, to test the text rendering, because that's the only glyphs I implemented so far. Fake Adidas pants, yeah. Okay. Maybe I'm gonna start with the building. Right, so here we are going to have the platform, WASM platform, right? So this is the WASM platform. WASM. And here we're gonna do the platform SDL platform, and then we're gonna have a similar thing, but instead of SDL we're gonna have a term platform, and we're not gonna link with SDL2. Right, and also here we have .sdl .term. There we go. Cool. As you can see, we have like 3 different platforms: WASM, SDL, and term. Okay. So now I'm gonna go to 3D, and there are some things that I want to copy paste from here. SDL platform. If def rather, right? So this is what we have in here, and I'm going to replace this thing with that. So this is the S. In fact, I can actually copy paste the whole bottom part in here because it's completely application agnostic. Right, it doesn't really care, right? There's nothing in here like really. In fact, I can probably take this part and make it part of the library. Even though it kind of makes the library depend on some things, but you can actually choose what you can depend on. Right. That's a very interesting idea, because this thing doesn't really care about what's going on up there. It's just like doesn't. You can copy paste this piece of code. Wow. All right. Let's try to build this entire thing and see if it fails or not. Okay, so 3D it compiled. This motherflipper compiled. This motherflipper just compiled. Okay. So let's do bin 3D. Okay, so this is the original application. So maybe in 3D, scale down factor, I'm gonna actually make 10 just to make it a little bit bigger, right? So, because I'm pretty sure if I make it too small, we're not gonna see anything, right? It's gonna be noise, right? So let's actually start with a little bit higher resolution so we can see shit in this mist. Right, okay, so it's been 3D. So here's the original one. I'm gonna zoom out a little bit. Well, I mean, yeah, so everything works. And let's try term. It works, as you can see. So that's pretty cool. This is so cool, holy shit. Right, so yeah, bitrate is kind of like, but it kind of works. Right, so, and the original thing actually is supposed to look like this, right? So that's how the original thing is supposed to look like. And this is the terminal version, so we redirected rendering to the terminal, but it can. So I'm gonna commit all of that, and you'll be able to, like, you know, test it on your machine if you want to. Right. So that's pretty cool. Yeah, that gives me a lot of interesting ideas in terms of, like, maybe in fact this part can be moved into the library, and you can just have predefined entry points for different rendering methods if you want to. Right, so that sounds like a very interesting idea. I think I want to go that route. All right. Implement terminal rendering. Right, and I'm gonna push that right into the repo. You can find the source code for all of these things in here. So the library is called Olive.c or Olive.c. Right, so yeah, isn't that cool? do you still need font? I made one, but it's still 6/8 star. Okay, try to post it in like Pastebin or somewhere. What is Olive.c? This is literally the library we are developing here right now. This is literally what we're developing. That's the name of this library. That's the name of the library that can do this kind of shit. Right. So, let's take a look. Okay. All right. That's pretty cool. All right, let me see. I'm not sure how to use that, so I'm not sure about what's that though. So because the only thing I need is that part, right? This one. I'm really not sure what's down there. We can give it a try. Okay. So I'm going to try that in here. Really? Come on. And some of them... okay, so I'll have to spend too much time. Okay, I'm sorry. It's too much effort to actually make it work. I'm not gonna do that, so I'm sorry. Right, okay, so does anyone have any questions? Because I think I already streamed for 2 hours, right? I'm already streaming for 2 hours, so does anyone have any questions? So, I'm sorry, it's not immediately copy-pastable and testable, I just like don't want to spend some time. Sorry, nothing personal. I'm just a very lazy person, For blending for ASCII rendering, I mean ASCII rendering is using rect fill, and rect fill can do alpha blending, so it works automatically. Is the music provided by this bot available online as a collection somewhere? I have no idea. What I'm using is that I'm using pretzel.rocks, right? I'm using this service. Right, and it just basically plays whatever random music it like plays. It's a bomber music. I don't know. So that's what I'm listening to. And in fact, the bot actually spams the links. I don't know. But oh, the question is it like provided as a collection? Probably not, because like I just say play a random song and that's it. Do you have VOD backup? Probably some Olivet's VODs are gone. No, they're not. It's copyright free, that's the point. And you know what's funny is that when I upload some of the VODs, they still get copyright claimed. So nice, copyright free, that's so cool. I mean, maybe they are copyright free in the Twitch space, but as soon as you move to YouTube, that's a completely different story, right? So maybe they don't have such agreement with YouTube, right? So maybe they only have agreement with Twitch. So it could be complicated, but I'm not a lawyer, so I don't know. Well, the copyright claims on YouTube is DMCA trolls, yeah. Oh my god. Okay, so what if we compress some stuff? I wanted to do revert. Please revert buffer. Okay. So I want you to go to 3D and actually make 40 and see how that cube, how that rotating cube is going to look like if it's compressed, right? So I just want to see it being compressed. Yeah, so this is how a compressed version of the cube looks like. So the original is supposed to look like this, and this is precisely why I didn't want to make a small resolution, because you won't be able to see that because it's a very small thing. But with the triangle, right, with the triangle, the small resolution actually works relatively well. Relatively. In C is simple and powerful, Java is coffee. I wouldn't say that C is powerful. C is as powerful as you are. That's why a lot of people hate C, because it exposes them. All right. Do you get money from the YouTube videos? I literally answered that question thousands of times. At this point, I think people ask that question just to troll me and just to remind me that I don't get any money from what I do. And again, the same question. Yeah. That's what makes it powerful. You make it powerful. That's what you mean, right? You are supposed to make it powerful. C makes you learn programming, yeah. All right, so I guess that's it for today. Thanks everyone who's watching right now. I really appreciate it. Have a good one, and I see you in the next recreational programming session. That's right. So yeah, I hope it was fun. It was definitely fun for me. Love you. Mwah.